Hi guys, today we have an special video related with the corrosion issue in a Benetti 134 feet. Yesterday I visited the boat. The customer complained about the corrosion in the frames of the air conditioning units. This is a wonderful boat with a great engine room. The air conditioning unit, the chiller units, are supported over frames fabricated in aluminum, and those frames are corroded, and the captain have a suspicion that the problem is electrolysis. We visit the boat, and I follow the process that I follow in other boats, exactly the same. Number one, check the pedestal and check if the ground of the pedestal is in good condition. Number two, check if the hardware used in the boat is marine grade hardware. In this particular case is great, it's a good boat, it's a clean boat, it's a dry boat. The hardware used is marine grade hardware. And also the other step is verify if the boat have a galvanic isolator. In this particular case, the boat doesn't have a galvanic isolator, no galvanic isolator. This is not good because if the pedestal, the ground is contaminated, if the ground is not good, some currents enter in the boat, affecting the boat, accelerating the corrosion. In this particular case, we found that the voltage in between neutral and ground more than 0.7 volts. In some cases 1 volt, in some cases 0.7 volts. This is too much. The voltage between neutral and ground should be 0 volts. Okay, this is the first problem. We checked the pedestal, and this one was the procedure to check the pedestal. Okay guys, today we are going to start the survey process for a corrosion issue in this Benetti. How long is that Benetti?
132.
132 feet. And we are going to start checking the pedestal. And we are going to verify if the ground in the pedestal is good. In this particular marina, of course, this is not the place of this boat because this is a marina and the boat lives in another place. But only today for purposes of verification, we are going to check the ground of this pedestal. I am going to check the voltage between neutral and each phase, and I am going to check the voltage between neutral and ground. Normally the voltage between neutral and ground should be 0. But I found that 1 volt between neutral and ground. This is a bad indication. This is an indication that something happened in the ground of this pedestal, but this is not a problem of the boat. This is a problem of the marina. Okay, we are going to verify that. The readings, please. Texture. Okay, how much is the reading between hot and neutral?
You got 282.1.
The second one?
282, that's the same.
The other one?
The same, 283.
Okay, and now between neutral and ground?
Just 0.
0 point something?
0.7.
Okay, that's too much. 0.7?
That's correct, 0.7.
Alright, thank you. Alright, ready. Now we are going to start checking inside of the boat. Checking for the condition of the bonding, the condition of the grounding, and checking if we have a leak of current in the AC panel and DC panel. Okay, and now we are going to enter in the boat and we are going to verify how is the condition of the bonding. We are going to use the silver chloride electrode. We are going to introduce the silver chloride electrode in the water. We found a window through the garage door to introduce the silver chloride electrode. Remember that according with the table, the reading for a good protection, this is a fiberglass boat, and this boat is working in salt water. A good protection should be between minus 0.8 volts DC and minus 0.95. This is a good protection. If you have a reading between minus 0.95 and minus 1.05, the protection is good, but this is not good for aluminum boats. This is not the case because this boat is in fiberglass. Okay, we are going to check the readings and we are going to verify what happened. Okay, now we are going to introduce the silver chloride electrode. In this boat, the access to the water is difficult. Finally, we have a small window in the bottom of the boat, and additionally, we found that the bonding conductor strip metal pretty close. Now I am going to show the condition of the bonding conductor, and we are going to verify with reference to that bonding conductor if the boat is properly bonded. Remember, the first step is check if the bonding is in good condition. What is the meaning of that? If all the metallic elements inside of the boat are together and connected with the bonding strip metal, with the bonding conductor. With this element, with the silver chloride electrode, we are going to do that process. The other end of the silver chloride electrode will be connected in the ground terminal of my multimeter. My multimeter set it in volts DC. Okay, and now the silver chloride electrode will be introduced here, and now with this one I am going to check the condition. Let me show in the table how it should be the readings. That the reading should be between minus 0.8 and minus 0.95 is properly protected. Maximum minus 0.8 until minus 1. Between those range are properly protected. This one means between minus 0.95 and minus 1.0 is not recommended for aluminum hull. However, the hull of this boat is fiberglass. We have a good range to check if it's properly protected. We are going to check in this moment is, look at this. If it's more positive than minus 0.7, it's not protected.
Okay.
Pay attention.
Okay.
Minus 0.7 is in the left side of the zero.
Okay.
Minus 1, minus 0.2, minus 0.7.
That's correct. Yeah.
If you have minus 0.4 or minus 0.3, is more positive and indicate that it's not protected.
Okay.
Okay. Now we are going to check. We are going to touch here the bonding, and the reading is minus 0.5. The boat is not protected.
Okay.
Simple.
Okay.
That's simple. That's okay?
Okay.
All right. We are going to touch the frame where the AC units are connected, and we are going to verify how is the protection.
Okay.
For example, here, minus 0.5 is not protected. That's the problem. That's the problem. Okay, as you can see, the reading is no good, no protection. The protection is not enough. My recommendation is install additional sacrificial anodes and verify if with the additional sacrificial anodes, bigger area, bigger plates, the numbers are better. I hope that only increasing the amount of sacrificial anodes, the problem will be solved. The next step is verify if the boat has a galvanic isolator. In this particular case, the boat doesn't have a galvanic isolator. This is the recommendation is install a good galvanic isolator in the grounding line. We need to cut the grounding line, insert in series the galvanic isolator. The recommendation is install the galvanic isolator and added more sacrificial anodes. The rest of the boat is in good condition, no reverse polarity, and the installation are great. The AC panel, the ground of the AC panel, and the DC negative bus bar of the DC panel, both of them are connected with the bonding conductors. The installation are in good shape. The only problem that we found in this boat is no galvanic isolator and not enough amount of sacrificial anodes.